So today's topic is regular expression and regular languages. So you all know that uh, the finite automata accepts the language, or it accepts the set of strings, and we call it as a language. And the language which finite automata accepts, that can be represented with the help of regular expressions. And because the finite automata accepts regular languages, regular expressions are also used to denote the regular languages. Okay, so you can see here in front of screen the regular expressions, expression formalism. So here you know that the regular expression over this input alphabet sigma, including your letters pi, it is for a empty set, and epsilon, it is for a empty string. So regular expressions will have the input alphabet that will include both your empty set and your empty string as well. And whatever symbol is there in that input alphabet, we can call it as a regular expression over the input alphabet. Now, if there are two regular expressions R1 and R2 over input alphabet, this restriction is always there, that the regular expressions, whatever you are designed, it will always be over input alphabet. Over input alphabet in the sense, we should use the symbols which are there in your input alphabet. So if R1 and R2 are the regular expressions, then R1 plus R2, R1 dot R2, and R1 asterisk, that everything will also be called as a regular expression. So here plus is basically used for a parallel path. Usually this is like your ORing, or this is just like your two parallel paths, like if else it is acting. When it is a dot, it is basically used for concatenation. So you can say it is indicating the sequential execution of the statement of a program. So you know that in your program you have a statement one after the other, and they get executed in that particular sequence. So this R1 dot R2, it basically represents the concatenations or sequential execution of a program. And R1 star, it is used for repetition or closure. So R1, the star, meaning the repetition is either zero or more number of times. So when you say it is a repetition zero or more number of times, so you can say it is just like your do while loop. So your do while loop, it gets executed at least once, but when it is executing zero times, so it can be your for loop, or it can be your while loop. So when it is R plus means the repetition at least once or more number of times. So R plus, you can say it is just like your do while loop. Okay. So this way you can formalize your regular expressions. So regular expressions will use the symbols which are there in the input alphabet, and it can include the empty set and empty string. Then every symbol in the in the input alphabet can be used as a regular expression. And if there are two regular expressions, R1 and R2, then there R1 plus R2, R1, R2, and R1 star, they also denote your regular expression. And regular expressions are only those that are obtained using rules 1, 2, 3. Now, as I explained, this already I have explained, R1 plus R2 is just like ORing, just like if else. R1 dot R2 is sequential execution of programs. R1 star, zero or more repetitions. R1 plus, it is at least one repetition, one or more repetition. So yes, one more thing here. So we can write this R plus as R dot R star. So R dot R star, it means zero or more occurrences. So if there are no occurrences, then there will be one R, one occurrence of R. So when you are concatenating this, so you will have one R compulsorily, and then later it is concatenated with zero or more repetitions. So as this R plus denotes, it is at least one occurrence. So this one, at least one occurrence, you can denote either with R plus or R dot R star can also be used to denote it. Okay. Now, if you have A plus B, if you have a symbols from input alphabet A plus B, then how you can convert this A plus B to finite automata? So A plus B, these parallel paths can be represented like this. So from state Q0, with input A, you are moving to Q1. With input B, you are moving to uh, Q1. So these two different parallel paths are shown here. A dot A, it means concatenation. So here after A, you are executing B, and R star here it is, you can see, zero or more number of occurrences of A. So this way A star can be represented. You can represent. Okay, now if R is a regular expression, then language represented by R is denoted by L of R, language which is represented by R. So if you have a regular expression equal to A plus B, if A plus B is your regular expression, then you can represent the language as A comma B, either A or B. If it is R is equal to A dot B, then here language which you are which it will represent will be AB. And if R star is your A star is your regular expression, then the language which it will represent will be epsilon, that is empty string, then comma A. Epsilon, it means zero occurrence of A, then A, one occurrence of A, likewise. So this way you could see that here language, it's a string, set of strings which can be generated. So depending upon what is your regular expression, here you will get the language. Now consider this example. Using a regular expression, describe the language consisting of all strings over 0, 1. Over 0 and 1, it means this becomes your input alphabet with at least two consecutive zeros. So you have to represent the regular expression where that regular expression will express all the strings which will consist of 0 and 1, but those strings should have two consecutive zeros. So if we'll say, if we'll try to find all combinations of 0 and 1, so you will get this as language. L1 is equal to epsilon, that is no input. Then at least 1, 1, at least 1, 0, 0, 0, 1, 1, 1, 0. So here this L1 contains all strings of zeros and 1, no restrictions, no condition. So this L1 will have all combinations of 0 and 1. But as per the problem, your language should have those strings which will have two consecutive zeros. So if you'll see L2, so here all the strings which are mentioned here contains two consecutive zeros, and that is the reason the strings which are there in L2 are all acceptable. So for we have to design the regular expression which will accept or which will generate these strings which are mentioned in L2. So if consecutive zeros are there, so these consecutive zeros are mentioned here, and before and after this consecutive zeros you can have any combination of 1 and 0. Either you can have only 1, either you can have only 0, or you can have any combination of 0 and 1. So that is the reason you could see here these two consecutive zeros are there, and after, before and after, you can have any combinations of 0 and 1.